Hello YouTube and welcome to my channel. This is part 2 of my talking microcontroller project. In this video we are going to program the ESP8266 to communicate with Home Assistant. Previously in part 1 I described how to connect the hardware up, and if you'd like to watch that video, click the link above. In that video I used Brian Locke's WeMos Mini breakout board, which allowed easy connections to the text-to-speech module. The hardware that's required for this project is pretty simple. We need a ESP8266. I selected the WeMos Mini D1. You can use a breakout board. I used Brian Locke's. You don't need that, but it makes it easier. I also used the XFS 5152CE text-to-speech module, an external amplifier with speaker, some wires to interconnect things, and then you need a programmer for the D1 Mini. I'm using a USB to micro cable and just using my Arduino environment to program the D1 Mini. On the screen you can see the pinout for the WeMos D1 Mini. As you can see, there's only a handful of wires required to connect up the text-to-speech module. Once connected to the text-to-speech module, you will have to change the baud rate. My program uses 115200 instead of 9600, which is the default on the hardware. If you'd like to build this project, I've provided the source code and I've created some PDF documents on my GitHub page. The link is in the description below. I had a few design goals while I was programming this ESP8266. Firstly, I wanted it to use Wi-Fi, and I wanted to be able to connect up to my MQTT broker to easily send and receive the messages or the payload. We want to have easy temperature and motion sensing. I like to have those features on all of my devices I make. I wanted it to have over-the-air programming so that when the device is remotely located, I can program it from my computer, which is located in the basement. I needed to support text as well as tones, alarms, the noises that are available on the chip. I wanted to be able to select voices easily. And mostly I wanted it to be easy to use with Home Assistant. If you decide to download my code and build this project, there are a few things you will need to change. You will need to change the Wi-Fi settings to reflect your home setup. So you will need to change the SSID, username, and of course the password for your Wi-Fi. You will also need to change the way the device connects to your network. This includes a static IP address, the gateway, and your net mask. Finally, you need to set up the settings for your MQTT broker. You need to know the username, password, and its IP address. Once you've changed those settings, the code should start to work, and you can follow along with the rest of the tutorial. I've written the code to allow for easy temperature and motion sensing. The temperature uses a Dell Semiconductor 18B20 one-wire temperature sensor. It is easy to use and there are readily available libraries and lots of tutorials online. For motion sensing, I'm using a passive infrared sensor. It measures whether or not there's motion in the room and goes high if there's motion and low if there isn't. Neither of these devices is required for the Home Assistant text-to-speech program that I'm writing. However, I like to add both of them to all my projects. This allows me to create sensor nodes wherever I locate my devices. Wherever possible, I like to use over-the-air programming with my ESP8266s. I learned about this feature at a site called randomnerdtutorials.com. I've added the OTA programming to the code, and there's lots of comments, so you should be able to follow along without any trouble. One of the design goals is to support text as well as tones or alarms. Sending the text is simple. You just pass it as a string. You can have the device create a sound, a tone, an alarm by passing it a square bracket x1 square bracket and then the sound number. The device creates many different types of sounds. Some I suspect were borrowed from Windows. Others are ringtones, and then the third group are alarm tones. There's even some Star Trek klaxon type sounds. The last design goal was to allow for selectable voices. The way I decided to do this was to pass the string or the payload with a square bracket and then the name that you want to set. Once we've got the device programmed and ready to receive the MQTT packets, we now have to look at the Home Assistant. Home Assistant uses YAML files for configuration and programming. I found there is a fairly steep learning curve on how Home Assistant deals with the YAML files. In this case, there are 4 YAML files being used. The analog sensor for the 18B20 is defined in sensors.yaml, while the binary sensor for the on-off for the PIR motion sensor is defined in binary sensors.yaml. I keep all my automations in an automations subfolder and name them according to type. So my XFS 5152cs.yaml will take care of all of the automations for this device. The automations I've created include motion, no motion, clock on the hour, and clock on the half hour. There's a very simple script installed in scripts.yaml called mqtt_tts, and it merely sends the message as a payload to the device. This process probably sounds more complicated than it really is. A simple example showing an automation that sends the message "Hello World" to the script. The script in turn takes that message and sends it over the MQTT network to the topic HA/TTS/action. The device we're making then grabs that message, processes it, and acts on it. Taking this a little further, it's a fairly trivial matter to make an alarm clock. Here you can see a condition that after 8 a.m. and before 10 p.m. we will send out a message every hour on the hour that the time is such and such o'clock. Note that we're also sending a sound number 205, to alert the user that there is an incoming message. Okay, we have everything connected and we're ready to give it a test. You can see that over here we have a cable going to my computer on a USB cable. That's providing power to the WeMos Mini. We have the text-to-speech module sitting here. The baud rate selection dip switch. Over here we have a passive infrared detector. It will detect when motion happens. When it turns on, we have the software turning on an LED. Over here is, let me pan up a bit. Over here is the 18B20 temperature sensor. And down below we have our connections to the amplifier. Pan over to the amplifier so you can see it. The amplifier is just a computer set of speakers that has an amplifier built in. It's powered. I'm now going to reset the WeMos Mini.
Text to speech module ready. Connecting to wireless. Wireless is now connected. The temperature is 19.94 degrees Celsius. Connecting to MQTT. MQTT is connected. It is 11 o'clock.
Okay, now we get this out of the way and we bring up our lens. You can see that I can take this and send a message.
It is 10 o'clock. It is 1 o'clock.
And here would be a different sound.
It is 1 o'clock. It is 1 o'clock.
That pretty much concludes the testing of the text-to-speech module. Now we can make our devices talk. I realize Amazon Echo and Google Home can do the same thing with TTS. I've got both of those devices and use them all the time. However, this little device for about $10 to $20 is going to be great for those remote locations where maybe you want to alert somebody of a situation. With the built-in PIR and temperature sensor, it becomes a sensor node, which is awesome. You could very easily add a power FET and turn on a siren, so now you could have a talking security system built into one little box. Because we've enabled it to use the MQTT messaging system, Home Assistant has no trouble whatsoever to send messages, sounds, whatever you dream up in your automations. If you'd like to download the source code or any of the documentation, just check out my GitHub page. I've left a link in the description below. Once again, thank you for watching. I hope you appreciated the work that went into this. It was a lot of fun. If you'd like to see more videos like this, please consider subscribing. Thank you once again.